Welcome everyone. In today's masterclass, we're going to build the quintessential portfolio project. I'm talking about the one that will help you ace your cloud certification and absolutely shine in your job interviews. So get ready, because we're building a production-grade AWS 3-tier architecture using Terraform.
So here's our game plan. We'll kick things off by understanding why this capstone project is such a big deal. Then we'll build our network foundation from scratch and lock it down by securing all the tiers. After that, we'll dive right into the Terraform code itself before, finally learning how to take this thing to production and test it like a real pro.
All right, first up, let's talk about our capstone project, the classic 3-tier architecture. This is a core pattern in cloud engineering for a reason. It's all about separation of concerns. By isolating the web, application, and data layers, we make the whole system more secure, easier to scale, and way easier to maintain and troubleshoot down the line.
So here's the bottom line, and this is super important. Mastering this single project, it's your proof of concept. It basically screams to hiring managers that you understand networking, you get security, and you can handle complex real-world infrastructure using code. It's a direct ticket to proving you're ready for a professional cloud role.
Okay, let's move on to our foundation. You can't build a house without a plot of land, and you definitely can't deploy an application without a solid network. In the world of AWS, this all begins with the Virtual Private Cloud, or VPC.
The easiest way to think of a VPC is like your own private, logically isolated data center that lives inside of AWS. It gives you total control over your virtual networking environment. We're talking your own IP address ranges, your own subnets, route tables, network gateways, the whole shebang. Building this network is a really logical 4-step process. First, we define the VPC itself. Then, we slice it up into public and private subnets, which helps us isolate our resources. After that, we configure route tables to tell the network traffic where to go. And finally, we attach an internet gateway so our VPC can talk to the outside world.
With our network all set up, it's time to build the digital walls between our tiers. To do this, we'll use AWS security groups. Think of them as stateful firewalls, which is just a fancy way of saying they automatically allow return traffic. This lets us really enforce that principle of least privilege and control traffic flow perfectly.
Now, what's really cool about this slide is how it visually enforces our security rules. Look closely. The source for the app tier is the web tier's security group, not just some random IP address. And even more critically, check out the database tier. The only source allowed to talk to it on the standard MySQL port is the application tier. Nothing else can get in. That right there is least privilege in action. All right, theory's great and all, but let's get our hands dirty. It's time to look at the actual Terraform code that brings this entire architecture to life. We're going to turn our design into reality with just a few simple commands. Now, to write really effective Terraform code, we've got to understand 4 core features. First, you have providers, like the AWS provider. They're basically plugins that let Terraform talk to a specific cloud API. Then you have resources, which are the building blocks, like an AWS instance or an AWS VPC. Input variables are what make our code reusable, letting us pass in values like a region or an instance size. And finally, modules let us bundle all those resources together into neat, reusable components, like a complete networking setup.
And then this happens. It's kind of like a rite of passage for every Terraform user out there. You write your code, you run Terraform plan, and you're hit with a frustrating error just like this one. You've hard-coded an Amazon Machine Image ID and, oops, it's no longer valid.
But what is Terraform actually trying to tell us here? This isn't just about a bad ID. It's really about having a fragile design. So the real question is, how do we fix this for good, so our code is resilient and we never ever have to manually update this thing again? And here's the brilliant solution. On the left, you've got that brittle, hard-coded ID just waiting to fail. But on the right, that's the production-ready fix. Instead of a static value, we use a Terraform data source to dynamically query the AWS API. It basically asks, hey, what's the newest Amazon Linux AMI available? And fetches that ID for us every single time we run our code. Problem solved permanently.
Okay, so now let's level up. We're going to take this from a personal project on your laptop to a full-blown, production-ready system that an entire DevOps team can collaborate on safely. And that means we have to talk about managing Terraform's state.
You see, the state file is basically Terraform's brain. It maps your code to the real-world resources it's managing.
Storing it on your own machine is totally fine for a solo project. But in a team, it's a ticking time bomb. If two people run Terraform apply at the same time, they can corrupt that state file, and that could lead Terraform to destroy or totally mess up your entire production environment. Yikes.
We solve this with a simple 4-step process. First, we create an S3 bucket to store the state file remotely. Second, we create a DynamoDB table to handle state locking. This lock is crucial. It makes sure only one person can make changes at a time. Then, we just add a backend S3 block to our code and run Terraform init to get everything synced up. Trust me, this is a non-negotiable skill for any professional Terraform user.
Awesome. Our infrastructure is deployed. But wait, our job isn't done yet. I mean, how do we know it actually works the way we think it does? And how can we integrate this infrastructure with other automation tools and scripts?
The journey doesn't just stop at Terraform apply. For a truly production-ready setup, we need to write automated tests. Frameworks like TerraTests let you write code that deploys your infrastructure, runs checks on it, like, hey, is the web server actually responding? And then tears it all down automatically. We can also use Terraform's outputs feature to pass information, like a server's IP address, directly into a Python script for any post-deployment configuration we need to do.
And this right here really shows off the beauty of Terraform. The skills you're learning are totally transferable. Notice how the core language, that resource block structure, it stays exactly the same. We just swap the AWS provider for the Azure M provider and change a few resource-specific things, like changing instance underscore type to size. The fundamental workflow? It's identical.
So, there you have it. You now have the blueprint for a production-grade system. You can build it, you can secure it, and you can manage it as part of a team. This leaves us with the final and I think most important question for any cloud engineer. Your job is never really done. How will you take this foundation and continue to secure it, scale it, and evolve it for whatever comes next?